This is a very simple introduction into secret sharing schemes. You don't know what this is or for what such a scheme could be useful? This video will give you a very simple introduction into, yes, exactly, secret sharing schemes. But before we start with the technical stuff, let me introduce this little girl. Her name is Alice and she will create with us such a secret sharing scheme. This here on the right is her good friend Bob. And together they own this mysterious box. You want to know what's inside? Yes! Inside the box are the candies they've just collected during Halloween.
Happy Halloween!
And as you can see, they were quite successful. But it's already quite late. It's time to sleep soon, so let's close the box for now. Fortunately, they chose a box which includes a code to lock the box, so the candies can be safely stored inside the box during the night. So Eve, the candies are safe against thieves. For Alice and Bob, it remains to figure out how to distribute the code between each other. And this brings us to our first very simple secret sharing scheme. Our secret here is the code of the box shown as 9687. To distribute the secret between parties, which are in our case Alice and Bob, we just copy the secret to both players, Alice and Bob. Now nobody besides Alice and Bob are able to open the box, so the candies are safe against thieves. Voila, we just built our first secret sharing scheme. But wait, Alice does not look happy with the solution. She's afraid that Bob will eat all the candies during the night, like last year. So this does not look like a solution Alice is happy with. But she has an idea how to solve it. What if we split the secret into 2 shares? So Alice gets the first 2 digits of the code and Bob the last 2. That is another secret sharing scheme. In this scheme, the shares of both parties can recover the secret by just merging both shares together. Let's think together with Alice and Bob if this might be a fair and secure solution for both of them. Go ahead and pause this video here until you had some time to think about a conclusion. Bob looks happy because he understood that this scheme is fair. He has as much information about the secret as Alice has. But why does Alice look unhappy? If one party knows already 2 digits of the 4-digit long secret, then the code can be easily figured out by just trying all the 100 possibilities for the missing 2 digits. To find a more secure secret sharing scheme, the question we need to solve is how can we reduce the amount of knowledge that each party has about the secret while staying fair? Again, it's time to pause the video to think about a possible solution. Let us know in the comments how you would solve this problem. Yes, exactly. We need to include some randomness to the shares while still being able to recover the secret. This can be done by choosing the first share randomly and then computing the second share such that the first and second share together add up to the secret. Since the first share is chosen completely random and the second share depends on the first share, both shares alone give no information about the secret, while the sum of both shares give full information about the secret. Alice looks quite happy with the solution, but Bob did not yet really understood how they can recover the secret later. So let's look at this in more details. If Bob and Alice wants to recover the secret together, then we have the following situation. Alice and Bob know the given shares, and together using the shares, they want to compute the secret. To do this, they just need to add the share of Alice and the share of Bob together, and to ensure that the secret consists out of 4 digits. or in other words, that it will result in a number smaller than 10,000. For this, we will take the sum modulo 10,000. And then this will result in the secret. So more precisely, this means we are adding 8505 and 1182 together, which gives us 9687. And since 9687 modulo 10,000 results again in 9687, we can conclude that the secret is 9687, which is correct in our example. Now it's just missing to perfectly understand how we are getting those magic shares that result into the secret. So in our situation, the secret is a fixed value in between all possible 4-digit combinations. And as Alice was suggesting before, we need to include randomness. So let's choose the first share randomly from the set of all 4-digit long combinations. Now, given the secret in the first share, we can compute the second share such that the resulting shares together will result in the secret. For this, we just compute the value given by this formula here. So let's make it more concrete. In our example, the fixed secret was 9687. We randomly chose the first share as 8505. Then, plugging in the values in our formula from above, we get this, which results into the second share that is equal to 1182. Using this last presented secret sharing scheme, Alice and Bob finally have shares that on one hand describe a fair secret sharing scheme, and on the other hand includes shares that reveal no information about the secret. With this, we can end this easy introduction into secret sharing schemes, and Alice can finally go to sleep peacefully. Please don't forget to like this video and click an abo so you will not miss the next video.